Welcome to today's lesson on dilations. It's the last of the 4 transformations that we're learning about. I'm going to be sharing my screen. Okay, so our TEK for today is 8.3c. Our lesson target is I will use an algebraic representation to explain the effect of a scale factor applied to two-dimensional figures on a coordinate plane. So remember that algebraic representation just means math rule. Scale factor, we know that scale factors are used for dilation. We use K to represent scale factor. So today we are talking about dilation. And the essential questions are, what does a scale factor greater than 1 mean for a dilated shape? What does a scale factor smaller than 1 mean for a dilated shape? Okay, so if the scale factor, again, we're using the letter K to represent scale factor. I don't know why it's K. It should be S. It should be SF, but it is K. So K is the scale factor. If it's greater than 1, then we know that the shape gets bigger. And if K is less than 1, we know that the shape gets smaller. Lastly, if K is equal to 1, the shape stays the same. So remember that all algebraic rules have to start off with x comma y. And then for dilation, the rules are kx comma ky. Remember that when you have a number and a letter, so remember that k is just a variable, right? So it represents a number. So when we have a number x comma the same number y, we're multiplying. So anytime we're dilating, we're multiplying. And if the dilation is smaller than 1, let's say it's 1/2, right? Which is the same thing as 0.5. You can either think about it as multiplying by 0.5, multiplying by half, or we know that fractions are the same thing as division, right? So if a scale factor is smaller than 1 and it's a fraction, then you can think of it as dividing as well. We do have a DOL. Okay, so we're going to go straight into this we do. So a polygon will be dilated on a coordinate grid to create a smaller polygon. The polygon is dilated using the origin as the center of dilation. Which rule could represent the dilation described above? So I know I skipped over the vocabulary, but center of dilation just means that it's a reference point used to scale the dilation of a figure, or where points are expanded, made bigger, or contracted, made smaller. And so, yes, the origin is often used as a center of dilation. So the origin being 0, 0. So the question is, which rule could represent the dilation described above? Okay, so we know that if the shape gets smaller, then our scale factor has to be less than 1, right? And so let's look at the answer choices, because some of the answer choices I see are not even for dilation. So we can go ahead and cross them out first. So A and B are not for dilation, they're for translation. And we know that because you're adding or subtracting to the x. Then our scale factor in C is 5/4, and our scale factor in D is 0.9. So 5/4, that is called an improper fraction. So improper fractions have a greater numerator than they do for a denominator. Or you can think about it the opposite way. The denominator is smaller than the numerator, right? And if we were to divide 5/4, because again, as mentioned, fractions are division, this would be 1.25. So we know that 1.25 is greater than 1, so our answer is D. And something to remember is that if it's an improper fraction, remember, when the numerator, the top number, is bigger than the denominator, then your fraction is going to be equivalent to a number greater than 1. Okay, then we have the next we do. It says triangle ABC was dilated with the origin as the center of dilation to create triangle A prime, B prime, C prime. Which rule was applied to triangle ABC to create triangle A prime, B prime, C prime? Okay, so first off, we can go ahead and use process of elimination because again, A and B are for translations. So they're not even for the correct transformation that we're talking about. And then the scale factor for C is 8 over 3. The scale factor for D is 3 over 8. So 8 over 3 is an improper fraction, so we know that it's going to be greater than 1. And then let's look at what happens. So we know that the inside, the smaller triangle is actually our dilated shape because it has the prime right here. So we know that the shape got smaller. So if the shape got smaller, then that means that the scale factor has to be less than 1. So if that's our case, then we know that the answer has to be D. Another way to do this to find the exact scale factor is to find a good point, right? So what I mean by that is, for example, B. B is a good point because it's exactly at one of the corners of the grid in the background, right? So it's easy to tell that B is at -5, 2. It's hard to tell what B prime is at, right? It's looks like it's close to -2, but it's not exactly on -2. And it looks just a little bit under 1. So those are not good points. A is a good point, but A prime is a little hard to tell. But C and C prime are our good points that we can use to find our scale factor. So we have C, then we have C prime. Okay, so for C, the coordinate for C is going to be 8, comma, -8. And then for C prime, we have 3, comma, -3. And so something that you have to remember is new over old. What does that mean? Well, first off, I'm going to just box off the side that we're using because we actually don't need both numbers, x and y. We just need x or y, right? So I like to choose positive numbers, and you should always choose positive numbers if you can. Sometimes it's unavoidable to use negative numbers, but here we have the x's are both positive. So our new has our prime, right? So we have 3 is our new. Our old is our 8. So we have 3 out of 8. So that confirms that our scale factor is 3 over 8. Okay, our next we do, it says figure 1 and figure 2 are similar figures. Which proportion must be true? So as a reminder, proportions are comparisons. And in this case, we have comparisons of fractions, right? Or comparisons of sides. So PQ represents, this top side on figure 1. Okay, so the way that I like to teach this is we look at the two shapes, and similar shapes are the same shape but different sizes, right? So it's clear that figure 1 is big or bigger, and figure 2 is small. Okay, so what I'm going to do is I'm going to choose a vertice or a corner. So I'm going to start with Q. Then I'm going to go in clockwise order and name the other vertices or the other corners. So we have Q, R, S, T, U, and then P. And then for the small, I have to find the corresponding side. So the corresponding side is the side that has also 3 curved lines. So that's going to be C over here. So you can see that figure 2 has been rotated from the orientation of figure 1, right? But we found that corresponding side, given that the angle notation is the same, right? It has 3 curved lines. Okay, so again, for C, we're going to go clockwise order and list the other sides. So we have C, D, E, F, A, and then B. And as you can see, I listed them on top of each other so that they're lines up, and that's very important for our answer choices for a reason. Okay, so if we have PQ, we can see that P's right here, Q's right here. In this first proportion for F, it says that aligns with B and C. So that is true. Then the other side says that TU, so that's right there, aligns with FA. So that other side could also be correct. So F is probably our answer, but before we go ahead and choose it, I want to go ahead and look at the other answer choices to make sure there's not an even better answer. Okay, so for G, it says ST. So ST right here is aligned to EF, right, or corresponding to EF, which is true. But then the other side says that QR corresponds to BC. So BC over here. So that part is not true. Okay, so then of course G is not going to be the correct answer. H is saying RS. RS right here corresponds to DE, so that's correct. Then the right side is saying PQ corresponds to EF. So EF is right here. So that is not true. So that is incorrect. So of course, then our answer is not going to be H. Then for J, we have ST corresponds to CD. So as you can see, they're not corresponding. They're not aligned. So that's not correct. So F was our correct answer. And then we have our last we do. For this problem, it says triangle MNP is graphed on a coordinate grid with vertices at M, -3, -6, N 0, 3, and P 6, -3. Triangle MNP is dilated by a scale factor of U with the origin as the center of dilation to create triangle M prime, N prime, P prime. Which ordered pair represents the coordinates of the vertex M prime? Okay, so then we only really need to look at M, right? If we're talking about M prime, we only need to know what M is. So M is at -3, -6. And if you look at all the answer choices, we see -3 and -6. Okay, so we're going to go through and eliminate the answer choices that are clearly not correct. So A and C are translations, because again, that's when we're adding or subtracting to the X and Y. And then B is dividing, which we know that sometimes the scale factors can be fractions, but D is the best answer because we have that we're clearly multiplying and we have the correct numbers that we need, which is X is -3, Y is -6, and we're multiplying by the scale factor. Okay, so the rest of the lesson is independent practice problems. Thank you so much for following along and see you in the next lesson.